This is the Unit 7 study guide answer key for questions number 1 through 7. Because of this unit study guide is not in the order by ELR, I'm going to reveal what I consider to be the ELRs as we go along, but all of the study guide videos are going in order with the paper, not by ELR. So, getting right into it, I've thrown some pictures on top of the screen to help me out to explain some of these things that we are going to be defining here in just a second. The first one on the screen says nucleus, so I'm just going to draw some arrows. You in your paper should be as descriptive as possible. Just because I do it on the screen doesn't make it the way it needs to be for yours. But nucleus is the central part of the atom, and the central part in the picture that I've picked happens to be right there. So it's the part that contains the protons and the neutrons. This, of course, is Rutherford's model. We know it doesn't really look like this, but that's what the nucleus is right there in the center. The next one on your paper is atomic number. Atomic number is the thing that tells you how many protons. So that's worth writing down. So atomic number is protons. And our two notations from class, they are that one for the isotope notation and that one for the periodic table notation. Notice that they're the same number because no matter what, copper is always going to have the same amount of protons, no matter what type of copper you have. The next one says atomic mass. Atomic mass is only found on the periodic table notation. So I'm going to draw kind of a windy arrow to get there. Atomic mass is right there. And this one tells us the average. So that's the one where when we talked about how there are different types of copper, and if you were to take all of the different types of copper and take their average mass, that's what the atomic mass is. And it's not found on the isotope notation because the isotope notation is one particular kind of copper, so it wouldn't make sense to put the average on there. But it does make sense to have a mass number, so I'm going to kind of switch colors here just to make sure that we're clear. For mass number, we're talking about just in isotope notation. It's going to be that one right there, 63, and this represents protons plus neutrons. The next one is valence electron. This is from the most recent ELR that we talked about when we were talking about Lewis models especially. But valence electrons are the outside electrons, so if I draw a line to this drawing, it's this outermost shell. So if we're drawing a Lewis diagram, and copper is not the best example for that, if we're drawing a Lewis diagram, then let's say we're doing carbon. Carbon is going to have 4 valence electrons. So 4 dots. So that would also be fair to represent valence electrons that way. The next one is isotope. This is just a fancy word of saying type. So if I'm saying an isotope of copper, I might mean this isotope of copper. There are several, though. Another isotope of copper might be copper 64, maybe. So another way that we might write these is the one that's represented on the page is copper 63. Another way to talk about it might be copper 64, or maybe even copper 61. They're all different types of copper, but instead of saying type in chemistry, we say isotope. The last one on the page is ion. This is when the electrons change. Electrons change, and what I mean by that is if you have neutral copper, and so I'm going to grab a different color here just to kind of represent what we're talking about. So I'm going to kind of grab this space up at the top right corner. I'm running out. But if we were to say copper like this, copper with no number right here. If we were to say copper like that, what we're talking about is copper that is neutral. So this is neutral. Neutral. Okay, and neutral copper just means that it has 29 protons, so that must mean it also has 29 electrons. They balance each other out. However, if you're going to write an ion of copper, that means that the protons and the electrons are not the same as each other. So I might write copper with a 1- charge. If it has a copper 1-, that means that it's got one more electron than it does protons. So this would mean still 29 protons, but it would mean 30 electrons because it has the -1 charge. So to kind of go backwards a little bit, isotopes are all about neutrons, and ions are all about electrons and changing those things. For the ELR numbers that go with this, all of these kind of mash into all the different ELRs. So I'm not going to take the time to go through each one, but these 7 questions kind of cover the span of the entire unit, and that's why they've come first.